To the second session of the AI crash course. We're happy to have you back here today with a talk about problem solving overall, but also problem solving, especially then with AI. We will do this in the normal way, where we have a welcoming session and now with just a brief introduction or to some of you that are new to this group, and then we'll do a quick check-in in smaller breakout rooms so that you get to know each other and get familiar with each other, connect, mingle, talk. And we also have a new check-in questions today. Then we'll go in through the crash course, of course. We'll do a short repetition of last time when we talked about what is AI, and then we'll go into today's theme on problem solving with AI, both problem solving overall, but also problem solving with AI. And then we'll do some breakouts with both break and breakouts, so that you get to the chance to discuss some questions around problem solving. And then I'll hand over to Jonna to introduce today's expert that will talk about her work within AI and machine learning. And then we'll have a summary, and then at 7:30 Central European Time, we'll end this session. But first of all, I would like to welcome up Jonna to the digital stage to talk about women in AI and what women in AI is.
Thank you so much, Peter. So welcome everyone to the second session, and my name is Jonna, and I'm a part of the Women in AI Sweden core team, and I head up the educational track, so therefore I'm here at the crash course. And just in short, Women in AI is a non-profit organization that is global, that works towards inclusive AI that benefit global society. So it's important for everyone to be a part of the development of AI. And we do this by running events, we do research, we do educational initiatives like the crash course. And in this case, we have partnered up with AI Sweden. And when I'm not working with Women in AI, I'm working at a AI consultancy firm here in Sweden called Substorm. And Substorm's mission is to make AI and intelligent automation available for more companies. And if you want to know more about why, you can always connect with me or Sophie here, that's also mentioned in the picture. She's the ambassador for the whole Sweden team. So reach out if you have any questions or connect, and we can always guide you through the Women in AI network.
Perfect. Thank you, Jonna. And this wouldn't be possible to do without Women in AI, who's a fantastic community of a global community where it's really about engaging, getting inspiration, connecting with experts around the world. And on the Swedish side, we have AI Sweden, which Raquel, Maria, and I represent. And AI Sweden is a neutral and national organization in Sweden with the mission to accelerate the use of AI to benefit our society. And that is really our core. How do we accelerate the use of AI to benefit something? And that is why the topic we're going to talk about today is so important around problem solving, because that is really how we create value. But one thing we need to do to solve real problems in the world of AI, and this is an image that Maria developed from last time, and this is really amazing that we are represented in this course in the entire world. So represented in almost all livable continents. We have multiple nationalities with your own challenges, your own thoughts about AI, and this is really what this course is about, getting a community, learning community, coming together, discussing things, discussing challenges, discussing questions you have early on. So one important thing here is really to get engagement and interaction among you. And we do this by using breakout rooms, getting you into different groups to talk about things. Raquel, this is today's questions. Your name, which one is your favorite emoji, and have you learned anything new in the last 2 weeks? And I would like for you to just do an example to answer this before we send everyone out in breakout rooms.
Thank you, Peter. I will do my very best. So my name is Raquel Sanchez, and I'm head of training at AI Sweden. My favorite emoji is, of course, the monkey holding the hands in front of their face, because I ask so many things of my colleagues, my friends, that I'm embarrassed so many times. The things that I have learned the last 2 weeks is maybe something that is out of the ordinary, but something really that we want to engage more in. And it's the international connections that we make within AI. We were actually, for 2 weeks ago, we were at our partners, Applied AI in Germany, Munich, and they had so many ideas to share, so much built around the structured capital, around how to work with AI hands-on. They have gone through so many use cases. They have academy built around this, so it was really, really impressive. And I think that the learning that I got from there is really to kind of engage partners even more and create more working groups, because that is, I think, the best way to co-create and learn together. So that would be my learning, Peter.
Great learning. I couldn't agree more around the international collaboration. So what we want to do now is we want to spend about 6-7 minutes for you to go into breakout rooms, answer these questions. I will send you out to them now. If there's any questions, you can always return to the main room to ask. I will stay here just in case, and you can call me into the rooms. But answer these questions, your favorite emoji, and also what have you learned in the last 2 weeks, so that we get the learning community going for today. So please join the breakout rooms, and I'll see you here again in 7 to 8 minutes.
Peter, I will stay in the room here.
Yes.
This time.
Ja, men det är jättebra. Jag tänkte att jag kanske ska pausa in. Maria. Welcome back to the main room. We would like to hear some reflections on learnings from the rooms. Please use the chat to write your latest learnings and your favorite emojis. But do we have someone that would like to share their new learnings from the last 2 weeks openly with the group? Otherwise, you will be forced to listen to mine if there's no learnings. Farshad, yes. Yes.
Because I was disconnected through my explanation in the room, and I want just to continue my to my roommate. I learned 2 or 3 items during these 2 past weeks. The first one, can you hear me or not?
You are breaking up a bit.
My connection is okay or not?
You're breaking up. So it's now we can hear you better.
So let's take the ball to the other person to correct my connections.
Yeah. Perfect. and we see in the chat is filling up with both learnings and favorite emojis, the dance emoji, the happy emoji. I do have a recommendation if you want to YouTube. So just to give you a short background, my favorite emoji was previously also the monkey, the Raquel, or the party emoji, but this quickly turned into the Canadian flag as I'm new in Canada. And it's so much faster to write the emoji than Canada. But otherwise, this is definitely a recommendation for everyone interested in intelligence and in learnings. And I think we should probably do a reading group or something. But it's a book by Jeff Hawkins that called The 1,000 Brains. And it's really about the development of the neocortex and how that relates to how humans learn. And why I want to go into that is that that is definitely research that it's very new in terms of neuroscience, and that will affect how we view and try to develop AI for the coming years. So it's about multimodality, how the brain seems to kind of take in information from different centers of the brain. So definitely a recommendation. It's on Audible, and if there's someone that uses Audible, that's a fantastic audio book tour or audio book service from Amazon. But definitely worth to check out 1,000 Brains by Jeff Hawkins. And now we will go into the crash courses, because we have a really packed schedule today, a lot of things we want to go through. And still, like, if you have any questions, just as we mentioned previous, just raise your hands, write them in the chat, just talk out. Farshad, now you raised. No, okay, it was old hand. So use the chat, ask your questions, just unmute yourself, and we're very open for questions. So this is for the people that are new into the AI crash course. The first session, we talked about what is AI. Today, we're focusing on problem solving with AI. Next time, we'll talk about some real world cases using AI and where we stand today and where we'll be in the future. Then on the fourth session on the 8th of December, we'll do a deep dive into machine learning and deep learning, the more technical aspects of the technology. And then on the last session, just before Christmas, or 2 weeks to 1.5 weeks before Christmas, we're going to talk about society and the transformation with AI. One of the main overall goal, the reason why we're having this course. And if you haven't already, please join the Crash or Slack channel. It's really where we try to engage people, where we try to drive the learning community in between the sessions. And it's also a very lively community of global individuals interested in the field of AI. But repetition is the mother of all knowledge, and it's really about getting into setting things into context. And now you've had 2 weeks to think about AI as a technology. So we'll just go through what we did last time real quickly. We did the thought experiment around the meaning of Google emphasizing AI so much. And what I would like to do is to also set this into context. And for some of you that attended our junior AI change agent program together with we drive together with Hyper Island, you will recognize this. But Sundar Pichai in Davos a couple of years ago said that AI is one of the most important things humanity is working on, and he compared it to electricity or fire. What we need to understand then is how long this field has been in the making. It's not a new thing. It's been around since the 1950s or 1940s if we go back to Alan Turing and his paper around can machines think. But AI as a term, as a suitcase term, was coined by John McCarthy and Marvin Minsky during the 1956 Dartmouth Conference. These group of gentlemen tried to solve some of the challenges for 2 months that we are still working on today. And what we see as the field of artificial intelligence, which is a research field within computer science. It's definitely how we try to both mimic human intelligence with different sets of technologies. We have speech recognition, we have natural language processing, we have machine learning, we have pattern recognition. But what we see as AI today is definitely the research field, the subfield of data science. And the convergence of the advanced mathematics, advanced statistics, and computer science. So we have the field of AI, and within the field of AI, we have a subset of those technologies like machine learning, and in machine learning, you have a subset of machine learning technologies like deep learning, as an example. And we also have a very broad technology landscape. So when we talk about AI in a more public sense, often we mean machine learning and deep learning, but we can also talk about neural networks. We can talk about chatbots sometimes. We even talk about robots as a part of AI, but this is really what we need to demystify and to clarify in the field, and that is our field, our role as people working in the field of AI, making the rest of the world understand the potential of this toolbox we have. We also talked about this, that the reason why AI is happening now, it's really the convergence of three major shifts. It's the algorithmic advancements that is being done within research and mathematics, the explosion of data that's a result from us using the internet, especially in the ways we are using it, and also computational power. Cloud services making computational power more accessible, the Moore's law making transistors and computation cheaper for everyone. So it's really not a democratization, but it's definitely making computation more accessible. And that is why we now are seeing a shift towards machine intelligence, and definitely some really, really interesting results we're going to talk about here today and during the next session. Then we mentioned AI today, and AI today has a lot of focus on the services we use every day. There's a lot of consumer technologies that are using machine learning and deep learning as a part of recommendation systems. For example, Spotify is using machine learning for their Discover Weekly function. The YouTube algorithm, or the rabbit hole of YouTube, as we call it, is definitely an effect of machine learning. You're using machine learning components in every time you do a transaction, because to detect potential fraud, banks, payment providers uses machine learning and AI technologies to scan all of those transactions. You're using machine learning in Siri, in Alexa, in Google Home, and also we're seeing now self-driving vehicles on our roads. For example, the minibus over here is from my hometown of Gothenburg and Lindholmen. It's actually in traffic, and it's a self-driving small bus that drives around people at Lindholmen. But we're also seeing applications in robotics, in manufacturing, and in healthcare. So we're really in the phase right now where we're starting to see solutions being deployed broadly in different industries. So what I wanted you to remember from last time is that AI is a toolbox today that are being ready to use, but it's the matter we have, it's what you use it for. That's the interesting thing. Some will focus a lot on the technology, and that is important, but it's really what we make out of the technology. And that is why we're going to talk about problem solving here today. But just as intelligence, when we're going to talk about problem solving, we need to understand at first why. And keep coming back to the golden circle and a talk by Simon Sinek. But to really create an impact and to really create value, we need to understand why we do something. And the reason why I believe and AI Sweden believes in the transformation with AI is definitely because we see that it has a huge potential in being a tool, one part of the toolbox, or being a tool for solving a lot of the challenges that humanity face. Looking at the SDGs or the Sustainable Development Goals from the UN, AI is not a single part, but AI can be one part of the solution in a lot of these areas. It's a part of a decentralization of power. It's a part of getting or understanding our problems we face more deeply. It's definitely a part of developing pattern recognition to understand what type of solutions we need to create. So I would say that the shift towards AI and why you are here should be aligned with the SDGs and what we're trying to achieve with problem solving in today's society. But keep coming back to the quote from Sundar Pichai and why this is so interesting is that even though the AI has been now around for 60, almost soon 70 years, we're still very early on in the development phase. We have some very interesting tools already. They're creating values for some of the biggest corporations we have in the world. But what we need to also understand is if we compare it to electricity, we need to understand how much of time it took to create real value and solving problems with electricity. So this is being debated, but Benjamin Franklin invented electricity in 1752. Or he invented a part of electricity, but really the one that sparked electricity that is the foundation for creating lights or light bulbs. But it wasn't until 130 years later almost that the light bulb was invented. So you had a technology, but then we were waiting for the solution for 120, 130 years. And AI has now been around since it was invented, and the idea has been around for a long time, but it's really the 1956 Dartmouth Conference was the early days, like the foundational days of artificial intelligence. And now we're seeing some really, really interesting development in the field. And we're now ready to start creating value and solving real world problems with the technology we now call machine learning and deep learning. And this shift we saw in terms of deep learning was really 10 years ago. It was the ImageNet competition, and also when Watson beat the US Jeopardy or the masters of US Jeopardy. So it's still a new technology, and we're seeing a rapid development happening in a lot of areas, especially the areas where we have a lot of data. So for example, the Googles, the Facebooks, the Amazons, the Microsofts of the world are really pioneering, and to not mention Tesla, but are really pioneering the development because they have a lot of data and they understand what they want, what type of value they want the technology to create for them. So going back to Andrew Ng, who's one of the pioneers of AI, that he's in charge of Stanford, the human-centered artificial intelligence lab at Stanford. He's also the one that brought in, or one of the people that brought in AI on Google a couple of years or some decade ago, and also the ones that started democratization of learning and intelligence in form of that he started Coursera. And what he says here is that technologies in isolation is useless. And I think this is really something we need to think about, because we tend, in the field of AI, we tend to focus a lot on technology and not as much on the value we can create. And we have to shift the conversation to that, because AI technology is just a part of what we call the applied AI. And this is what I want you to really bring with you from this session, is that we talk about AI as artificial intelligence almost each and every day, but that's the field of research that is studying intelligent agents. That's a part of data science in an academic sense. That's a part of developing the toolbox. But then if we look at AI applications, that is really the products and services that use AI technology to create some type of value or create some type of solution. When we talk about applied AI, that is a process in where we get a bunch of people or a group of people together to solve a certain challenge. And to do so, we have to start thinking about problem solving and what we can do with AI today, what the toolbox consists of. So parts of, and this is a fantastic image developed by one of our colleagues, Connie Svensson, who heads up the our AI transformation team. And it's really about the effect of using AI. Not all of us need to be AI experts or machine learning experts, but what we need to understand is how we're going to use the technology to solve real world problems. Because now we have a toolbox that we understand. So we have image recognition as a part of our AI toolbox that understands, that makes computer understand the world around them. It can sense the world. It could recognize objects. It can understand images or video sequences. So machines now can understand the room which it acts in. It can understand language in some senses, where with the natural language processing as an example. So your Google can kind of understand what you're asking for when you're asking it a question, asking it to Google something. It's still, this is debatable, but it still doesn't understand context, but it can understand when you ask for something. And of course, we also have the understanding the world, seeing patterns, forecasting things, optimizing things. And if you read the book, 1,000 Brains by Jeff Hawkins, you will see that this is a really interesting area, because that is basically what our brain does in everything we do, is really forecasting things, trying to process information to make the best decision possible for our next action. So understanding this helps us going from a proof of concept in a technological way to a proof of value. And it's the proof of value that is of interest for the rest of the world outside of those doing research within AI. It's what we can do with the technology, how the technology can help us solve certain challenges, certain problems we face in our organization, or create new opportunities. But to do so, we have to work with innovation, because we have a lot of focus on feasibility, what is technologically possible in the in the area of artificial intelligence. It's definitely been a very weighted heavy towards research, but what we're seeing now is a shift towards desirability or viability, or hopefully both and all three of them. And it's really the intersection between what we as humans want, what will create value for our organization or our business, and what is technically feasible that will drive the adoption of AI, because that is where innovation happens. It's where we create value. It's where we create new solutions to problems we haven't had solutions to before. So then we have to ask ourselves, when we're focusing on problem solving, what will create value? And to do so, we have to understand AI and understand our organizational or business priorities. Then we can identify use cases and align with strategy. Then we can assess the technology, and then we can start prioritize what type of projects we should do. But if we start at the preparation phase, that is why you are here. That is why you're taking the AI crash course, to understand AI, so that you can shift your understanding towards focusing on potential solutions. And that is being intelligent. That is really about acquiring and applying knowledge and skills towards challenges you face. So one thing I want you to discuss after this presentation is basically how you solve problems. How do you tackle problems you face in everyday life? Do you have a certain methodology? What do you do? What is the first thing you do when you stand in front of a challenge or a problem at work or at home? How do you define the problem? How do you come up with solutions? And of course, this is being done in multiple ways. Sometimes you have very hard problems you have to think about for a long time, and sometimes it's more like, yeah, I need to do the dishes. Let's do the dishes. The dishes is piling up in my sink or something. But it's really about early on defining the problem. One thing we do often working with technology is that we skip the problem. We skip defining the problem. We skip defining the root cause of the problem. We skip defining alternative solutions to the problem, and we jump straightly towards the solution or the tool. And then we go around with the tool saying, yeah, I need to find a problem where I can apply this solution I've invented. But to create value, we need to find the challenges and problems we face. And if we look at the field of AI, what we need to be able to do, or what we need in terms of successfully deploying an AI project, is definitely that we already have a very well developed toolbox of models and algorithms. We have a lot of algorithms now. If you go into Google Scholar and you just put in your field of what you're asking for, if we are looking for federated learning or something, you can find a bunch of articles, some ready to use models in that are openly accessible. A lot of open source development is being done in machine learning. But what we need is to define a problem. And on that problem, we need data. And we need a lot of data to successfully deploy or to successfully train and deploy machine learning models. We need data on the areas you are interested in, and then we need to be able to train an algorithm to a model with the help of computational power. Because if we look at machine learning, which is the most popular AI technology right now, it's definitely, if you compare it to old software development without machine learning, we can write code in software development with very specific instructions. If this happens, then that should happen. And if that happens, then that should happen. So that is more specific-based or rule-based systems. In machine learning, what we do is that we don't write the rules. We don't write the instructions. What we do is that we train the machine or train the algorithm with the help of data. And we train it, and data is to be seen as experience. Because just as when you try to learn something new, you can read about it, but the most effective way of learning something new is definitely by doing it. So for this course, and that is why we're going to into the technical aspect of it for the fourth session, you will get to train and practice and experiencing training a model, because that is the best way to understand machine learning. But to train an algorithm, you need to define what you want it to do. You need to define where you want it to go. Because in machine learning, we use something called it's basically objective functions, which means that we have a goal and we want the function to serve us that or move towards that goal. And the way we go towards that goal is by training it on previous experience, which means data. And we can do this in multiple ways. So if we have the data and if we want to train a model, we can use either unsupervised learning as a subset of machine learning. We can use supervised learning, and we can use reinforcement learning. If we look at, for example, what we do in fraudulent detection in the transactions when you use your debit or credit card, there we can use supervised learning or classification, where we used our previous experience and labeled data of fraudulent transactions. So human teams in the bank or at the payment providers that I had identified fraudulent transactions for before. And what we used then, what we tried to do with the model then is to train the model on those transactions we've seen before to identify new potential transactions in our large sets of transactional data. If we look at reinforcement learning, which means that we try to reinforce different learnings into the model when we train, there is that is really an area we use a lot in game AI, and we will go into more in depth why we use games as a set of, or as a field to train algorithms and what it means. So just to give you a very quick overview of machine learning, you have input data, and then you have a machine learning algorithm that you've trained before. So you have a model input data, and then you either do a prediction or a classification of the new data coming in. Is this in the terms of fraudulent identification or fraudulent transactions? It's like, yeah, we highlight a certain type of transaction that, okay, you need to the bank team that you need to look into this transaction because we think, or the machine learning algorithm think, that this might be a new fraudulent transaction. And that gives us new data, because then we can say, yeah, okay, this is suspicious, or no, this is an okay transaction. And then we repeat that into the machine learning model so that get new data. So if we look at, and Kolb is a psychologist that looked a lot into experiential learning. And this is really how humans learn. We have a active experimentation. We do something, and then we have a concrete experience of that. We get some feedback from either the world around us or internally. Then we do some reflections about that. As an example, if I turn on my oven and then I leave it open for a bit, and then I touch something in the oven, I will definitely get burned, because the thing in the oven got warm. It was warmer than my skin. My skin got a burn, and that was my concrete experience. I reflected on what I was doing. I got some feedback from the outside world saying, yeah, okay, Peter, you should probably not do this, because that means that you will get burned. And then you do internally an abstract conceptualization of that, and then I know not to do that the next time. I should not put my hand in the oven while it's hot, because then I will burn myself. And that is how humans learn. In machine learning, we use the same type of methodology, but we need much more data, much more experiences than just one. And this is a huge set in machine learning that we want to do some more research on. How do machines learn quicker and faster? But that is really, if I want to do active experimentation and if I want to solve real problems, then I need to focus on the problems at first. What do I want to do an active experimentation on? What field should I do it on? So if we look at using machine learning in a type of problem that all of you have probably used this. It's definitely a search problem. Using, for example, Google Maps or Apple Maps in your phone, they will use machine learning to find the optimal route. And finding the optimal route is definitely, it has to do with, of course, you want to find the fastest one, but sometimes it's not about time. Sometimes it's about other types of resources and what type of resources and restrictions you're facing. So the problem solving in this part is that, yeah, okay, I want to go from point A to point B. If I'm in New York, for example, I want to go from Upper East Side to the Statue of Liberty. What I have then is that I have a search problem. I want to find the optimal route for this problem. The optimal route could, in one sense, be that I wanted to take the least time possible. And if I have an available chopper or helicopter nearby, and I have the amount of capital or money to fly there, it will probably present me that solution, because the air is definitely the fastest way to go, but it will definitely have an impact on the environment, and on my wallet. And so I have a restriction. I don't have the money to take a helicopter to the Statue of Liberty. So I have other types of restrictions than time, apparently. Time is one, but also my energy and the available resources I do have. So then the search problem is having an objective going from point A to point B, but also the problem involves different restrictions that I can only use this type of amount, or it can only cost this amount of money, or I only have this energy. And sometimes when we define a problem, we don't define the restrictions, and restrictions are super important in understanding what type of solution I should present. And that is the reason why AI researchers have used games a lot, because games are a super good field to start experimentation on, because we often know the goal of a game, we know what we want to achieve, and we know the restrictions. We know the rules in what we need to train the algorithms on. So, for example, in chess, and this is a very famous moment in time where the Deep Blue, the IBM model beat Garry Kasparov, the world champion of chess. And chess is a very good example because you have a limited numbers of boxes on the chessboard. You have a limited number of pieces that have restrictions in how they can move. And if I move in one way, then I know that opens up a number of possibilities in the next move. So if we look at the chess game tree, as we can call it, so every position opens up new potential moves for the game, and our goal is often to get or beat the other player. We want to do that. We want to make that chessmate, or bring our opponent to a chessmate position. So every position makes the decision tree bigger and bigger, and we do take decisions in that decision tree. And our end goal, our objective function, is to beat the other player. But what we also seen so far is for example, AlphaGo or a DeepMind going over to a more complex game. And the reason they are moving over to a more complex game like Go, that have more combinations than stars in the universe, is really that it's a super complex games. We don't have the opportunity to build the same type of solution that we did in chess. What we needed to do there is to use other sets of learnings in a game setting. And if you haven't seen it yet, definitely see the documentary AlphaGo on Netflix, because they will explain this even further on. But why this is so important, or why this is so interesting, and why this is so important, is that by trying to solve games, by trying to solve the Go challenge, or building the AlphaGo model, DeepMind were able to learn things about deep learning and how it solves different challenges, how it solves problems, so that they could apply those solutions outside of games on completely different sets, or completely different areas, like the grand challenge of medicine, the protein folding problem. And for those of you that don't know, protein folding has been a grand challenge of medicine because it's basically, if we solve that, we can have a quicker and faster and more resource effective development of new novel drugs that will hopefully solve cancer and a lot of different diseases, global diseases. And by training a model and learning from AlphaGo, DeepMind were able to also develop the AlphaFold solution that are on its way to solve the grand challenge of medicine, the protein folding problem. And the research that is being done within this field is now one example of how well developed the toolbox of AI algorithms or the AI toolbox is today. And now we need other areas like medicine, like sustainability, like social sciences, to understand how to use these tools available to solve their grand challenges. So going further and into the next thing, what I want you to think about is really, okay, there are a lot of tools today where we can sense the world, understand the world, create the world, do imitations of the world in a digital space. We can understand the world around us. If you had those tools, what type of data would you need to solve the problems that you are thinking about? What type of experiences would you need to gather to solve those problems? So I have two questions for you for a 7-8 minute discussion in the same groups. And that is really, how do you solve problems today? What type of problems are you facing and how do you solve them? And what problems would you like to solve with the help of AI? If you were able to understand the fields you're working in, and if you had data, what type of problems would you like to solve? So I'll send you into breakout rooms, and I think we have about, we will do a 7 to 8 minutes in the rooms, and then we'll go through the problems back here again. So I'll send you out in breakout rooms now.
How we should find a breakout room? Oh,
yes, they're here.
got it. Thank you.
Sorry, would you please repeat the name of a Slack channel or this channel?
Yes, I will send a link to the Slack channel just in the chat.
I've already done that, so you can find both the name and a link to the special channel.
Recording again. Welcome back to the main room, everyone. I want to know how the discussions were in the room, and if there's a room that would like to present what you discussed or how you solve problems today. Because I think there's a bunch of different techniques that you either do very consciously or unconsciously. So do we have a room that would like to present? Dean? Yeah, go on.
We can present. We talked about how do we solve our problems today? So we direct into like the searching engine, Google. Of course, the first thing we do there, if we have any kind of problem, that we ask Google, hey Google, shit, there's a problem. What should we do? How should we solve the problem? So this is the first thinking. And the second thinking, like this is really, we talked about this really interesting thing with AI and how we are learning from it as a human being. That we haven't learned that before, how to frame a problem, and how to think about it. So with that kind of technology that we are start to think about our own problems, how to solve our own problems. So, and we need to put it in a design thinking and a process, whatever the problem is, then the solution would come. But what we do actually nowadays, as my team agreed with that too, like we go direct to the solution. Anytime we have problem. So instead for finding out like what is the cause of the problem and what is the root of the problem actually. So so this is very interesting era for humanity to that learning from a technology that we have created. So this is what we discussed about. And we didn't get into that question, which kind of problem we wanted to solve with AI, because we got into that discussion there, and that was interesting.
Yes, and And a great reflection. Anna, I completely agree with your comments, so please speak up.
Yeah, thank you. Like I said, I'd like to leave the floor to younger colleagues, but since we only have the guys speaking, I'm gonna jump in and try to inspire my younger female colleagues in AI. Like I wrote in the chat, we have a really diverse group. So we had biobanking and medicine, which is me, lots of challenges. I talked about a tricky issue called consent. For instance, when you give a sample for research, they take a blood sample and then they put it in a deep freezer so that they can use it for medical research. In order to make that happen, you have to sign a paper-based form today. It's a piece of paper and you have to read it. It's usually 8 pages long or something like that. And you sign it with an actual physical pen. And that's how you give consent for your sample to be used for research. We would like to automate that, and that would make a huge difference in terms of understandability, explainability in general, and just really speed up the process, and also take out the often tricky sort of personal contact with someone who might be stressed out, who might not have the time to explain it to you properly, and so on and so forth. So that is something we're working on right now on the European level. And in our group as well, we also had accounting issues and transportation issues. So really, really wide berth of issues for us to look at.
And that is fantastic. And I think, I hope that these discussions will go on in the groups. I also see that you mentioned something really interesting about ethics earlier in the thread here. And I just wanted you to speak out on that for the entire group.
Yeah, I mentioned one of the issues in AI ethics is that one of the things we really want, of course, is trust. We want individuals to trust in AI, but in order for us to get there, we need to manage risks, because one of the best ways to build trust is to have sound risk management. And since people don't really know what's going on with AI, one of the main steps towards that is to actually really explain AI as well as possible. But the issue with that is that transparency is lacking in all of AI, because AI is so complex that, you know, the human brain can't really sort of deconstruct all of the different processes going on in the machine learning process. So, I mean, the humans can't really understand what went on. So how can we make this transparent and ethical, and therefore mitigate the risks and make AI trusted and trustworthy? It's a really tricky process, because transparency at the moment is impossible.
And yes, I couldn't agree more. So that is actually one of my challenges for today for all of you before we go into the next section of the agenda here, and that is to do exactly that, but do it on a human level. So try to get transparency into your or people around you, their decision making, because we talk about AI as a very complex system, but humans are also very complex. So and this is you challenging the world around you. So when you have someone making a decision for something, ask them not about the decision, ask them why they made that decision. How come did they choose that restaurant, or why did they present that in the way they did? Because then you also get an insight into how complex decision making is, and how we gather data and how we gather information. So challenge the world around you for the next 2 weeks and asking them, like, okay, so why did you make that decision? But not in a skeptical way. It makes like, okay, wow, interesting. Why did you make that decision? And with that said, we're going into the next phase. Jonna, I would like to hand over the digital scene or digital stage to you.
Perfect. Thank you so much. As we've informed you about, we have a guest speaker for the session today, and we will have Granjay McKnight joining us. She's a founding data scientist for Spoke AI, and they have a tool that, with the help of AI, make information sharing effortless. And she comes from a financial technology background and have built a number of different data products, all from intelligent chatbots to a model for detecting money laundering and fraud, as Peter has been talking about today. So a warm welcome to the crash course, Granjay, and well, the floor is yours.
Hi, thank you so much for having me. I'm going to begin sharing. Hopefully, see. Can you see my presentation slides now? Perfect.
Yes.
Yeah, Jonah's already done a great job at introducing me, but I will introduce myself a little bit more in a second. But first, I wanted to introduce the topic for today, which I think, based on what I've heard, is very relevant to what you guys are doing. So it's algorithmic fairness. And this is a fairly recent term. How I define it is the field of research aimed at understanding and correcting biases in data and algorithms. So this is researching their causes, finding ways to mitigate them, etc. With the goal, of course, to build fair algorithms. So you might ask, what does it mean to be fair? Fair is clearly a subjective term. But this is sort of a working definition that I like. Of course, fairness is different and depends on personal ethics, company ethics, cultural ethics, but also it is something that depends on context, even for one individual. But in machine learning, a given algorithm is said to be fair or to have fairness if its results and performance are independent of given variables, particularly protected attributes. And protected attributes are those that you can think of, the ones that you have very limited control over. So your gender, ethnicity, nationality, disability, sexual orientation, etc. Yeah, so that will be the topic for today. I'm going to briefly introduce some ways that bias can occur in data and algorithms with some real world examples. And then I think related to what kind of problems you want to solve in AI, some tips on framing the problem, because actually in framing the problem, that's a lot of the time where bias does come in. So yeah, this is me. Grania McKnight, as Jonna mentioned, currently working in Berlin with Spoke.ai. My background was mathematics and statistics. I'm Irish, which you might guess from my accent, not sure. But I studied in Dublin and moved into more traditional finance initially, but then moved to N26, which is a neobank in Berlin. Worked there for 2 years, built a chatbot, some financial crime models, and then lived in Amsterdam for 1 year and 9 months and worked there also in fraud detection. But that is really where I began to look into data ethics and sort of lead a working group there and discussions and really begin to learn, because there's so much out there these days on this topic, which is very exciting. Yeah. So I mentioned algorithmic fairness. Part of it is understanding biases and where they come from. So there are many ways bias can be introduced to an algorithm. These are 4 of the core ones that we'll see some examples of. So the first is in framing the problem. So framing a problem really for data science has 2 parts. First, figure out what is the problem you're trying to solve. And second, translate that problem into a language that a computer can understand. And where that can go wrong is what's referred to as the alignment problem, with the computer language doesn't actually align with the true goal that you're trying to solve as a human. The second is in collecting the data. So bias can show up in the data either when the data set is reflective of existing prejudices, and we'll see some examples of that, but also when it's not representative of reality. So of the true, for example, population demographics that we have. Another place where it can appear is in preparing the data, so in selecting which features to include in your model, but also in data cleaning tasks. So like something like survivorship bias is where this can happen. And finally, in model selection. So when you're choosing the algorithm to use, and I think this is really closely related to the discussion that you were having prior to this, because understanding why something makes a decision is trying to get at the causal model behind a process. So what is really causing something? And unless your model is built on a causal mechanism, it can be very difficult to make sure that there's no bias due to correlations with protected attributes. And that is something that deep learning models, for example, it's very difficult to control for. So these are the ways bias can be introduced. We'll see a few examples. So I really like this example for the alignment problem. I heard it on a podcast a long time ago. I tried to find the original source and I didn't find exactly this story, so it might have changed as it was being communicated. But basically, a father had two sons, an elder and a younger, and he wanted the older one to teach the younger one how to use the potty. And so he would give the older son a sweet every time he did that. But he discovered that the elder son started force feeding juice to the younger son to get more and more sweets. So yeah, this is where the reward function he defined was not aligned with his actual goal. An example that I saw recently very interesting was in STEM job postings on the internet. They're shown far more often to men than to women. And that is not because men engaged with them more, so they didn't click through more often. It's actually because men are cheaper to advertise to, which I didn't know, but apparently they're cheaper to advertise to. And the algorithm that decides which advertisement to show was optimizing for click-through rate for the lowest cost. And so it showed it more often to men. So that's another example of where what you're optimizing for is maybe not in line with your ethical, what you want ethically yourself, or we want. So data collection, you may have seen this before. I think it was shared quite widely not too long ago. This is Google Translate, and it's from Hungarian to English. And Hungarian, there are no gendered pronouns. So when translating from Hungarian to English, Google Translate has to decide whether to use he or she, or maybe doesn't have to decide, but does make that decision. And here you see Google's algorithm has translated they are beautiful, they are clever to he is beautiful, or she is beautiful, he is clever, he reads, she washes the dishes, etc. And why does it do this? Because it has learned from published text on the internet. And the truth is that in published text on the internet, she occurs more frequently with beautiful than he does, and he with clever more often than she does. So yeah, this is reflecting existing prejudices, but it is actually built on data. There's nothing, the data is real, but it's reflecting existing prejudices. I also mentioned with data collection, what can happen is when it's not representative of reality, you run into problems. A good example of that is in clinical trials. So I saw a paper that said that in clinical trials in the US, where 16% of the population is Hispanic, I think that was in 2011, so different now, only 2% of clinical trial participants were Hispanic, which means that the results and the efficacy figures from clinical trials are maybe less certain than they are for other ethnicities. And that's a problem. And yeah, again, an ethical concern. So yeah, that's data collection. There's another example, an image shown. This is from The Economist. It's basically labeled data sets that are publicly available. And on the axes, you see protected attributes. So the top one is gender, and the bottom one is skin color. And if you look at the skin color one, for example, how you can read this is there are, for example, 10 times more images of dark-skinned people who are labeled basketball player than there are light-skinned people. And there are approximately 10 times more pictures of labeled rich person with light skin than with dark skin. So if you're using this data then in your algorithm, of course, you can expect it to reflect these sort of imbalanced views of the world. Data preparation I mentioned. This is Amazon's infamous hiring algorithm. So they wanted to take CVs and use an NLP model to sort of predict or choose whether a candidate should make it to the first round. And it was trained on historical decisions that favored men over women. So the algorithm actually learned to do the same. And what the engineers discovered is it was explicitly penalizing the word women's. So if you had on your CV played women's basketball in college, for example, the algorithm would actually downmark your CV for that. So they found this and they were like, okay, we don't want that, of course. So they explicitly hard-coded it to ignore these gendered terms. But what they found was it instead began to pick up implicitly gendered words. So verbs that were more highly correlated with men over women, such as executed and captured, and using that to make its decision. So even that's an important lesson, I think, which is even when you exclude features that are sensitive attributes, you can still have a biased algorithm because it picks up on things that are correlated with those protected attributes. And this relates to model selection because they chose to use a deep learning model rather than build something up about a causal model of why actually are some candidates good hires and why aren't others, and how do we model that, and how do we use AI to model that. Yeah, so that is kind of the examples from the real world. Yeah, there is so much so many different methods out there to approach each of these problems, but I thought I would just give you a brief introduction to how to frame the problem, because I think this is very related to what you've been talking about today. And a lot of what I have here comes from actually Google's People and AI guide. And there are basically three things that are important to keep in mind in framing a problem. The first they mention is finding the intersection of user needs and AI strengths. So the way they phrase this, which I really like, is instead of asking, can we use AI to do this? Or rather ask, find a problem via user research and then ask, how might we solve this? And then the second question being, how can AI add unique value to the solution of this problem? And only if it can do that, actually employ it. The next one is to consider when to automate and when to augment. So when to take over a task from a human and when to assist a human with a task. So automate tasks that are difficult or unpleasant, and ideally ones where people who do it concurrently can agree on the correct way to do it. An example from the chatbot we built in our bank might be changing address information. If a human has to do that, it is unpleasant, difficult. We can all agree how it is done. So maybe let's allow a chatbot to do that. But then bigger processes are things that people actually enjoy, are things that are high stakes, and maybe those should be augmented. An example they had in the guidebook, which I really liked, is designing a t-shirt, for example. Like if you enjoy designing a t-shirt, you don't want an AI necessarily to do that for you, but you might want help with, for example, choosing colors that work well together. And that's where an AI can augment your experience of designing a t-shirt. Of course, high stakes decisions like deciding which medical treatment to have. This is something that perhaps should be left to be augmented. So a medical professional can get suggestions from an AI tool, but having a human in loop is still important, at least for now. And then the third tenet of how framing the problem is design and evaluate the reward function. So in the problem or the example I talked about for the alignment problem, the father's reward function was 1 candy for 1 potty visit. And because he didn't fully specify it fully enough, there was this unattended side effect. And this is why you have to be really careful in defining your reward function. So basically the computer translation of your goal. And I really recommend doing this with a cross-functional team. I think as a data scientist, it can sometimes be tempting to sort of assume a reward function or take that task within the data science team. But I've personally really benefited from discussing it with like product and tech and user research and really thinking about this deeply. So I will share this perhaps with you, Jonah, after for some of the links. There's lots of links here, but basically there are a lot of resources out there on this topic. One thing I would really recommend on the alignment problem is a podcast, the Ezra Klein Show at the New York Times. He has a podcast about this topic. I really recommend it. It changed how I thought about framing problems. There are a lot of tools out there for algorithmic fairness. I've listed a few there. There's, of course, tons of interesting papers. One that is especially interesting, I think, is the European Commission's white paper on AI, because they're beginning to really look at this topic and consider it. So it'll be interesting how they regulate it in the future. So that is pretty much it. A very brief introduction to algorithmic fairness. One last thing I want to say is that data ethics, it covers so much more than algorithmic fairness. This is just one part of it. So make sure, like, of course, you are also thinking about privacy, transparency, some of the other things that are really relevant to this topic. But yeah, questions welcome, discussion welcome, etc.
Thank you so much. That was a great talk. And we haven't had much questions in the chat, so please put some questions in the chat if you want to pass it forward to Granjay. We have a little bit of time, so I'm not sure that we can have that much questions, but I would like to ask one question that is very important for at least the Women in AI network, and that is, you come from a background from the financial perspective and not the computer science, traditional or engineering background. And what advice would you give a young professional that might want to switch sides and go more towards the AI side when it comes to working?
Yeah, so I've had a really interesting journey there, because my background was far more like mathematics, statistical, academic, and not at all let's say hands-on with software engineering skills. And it's really when I moved to N26 that I was thrown into the deep end. I, for example, had never used GitHub before going to N26, and I was there as a data scientist learning how to use GitHub. I think my advice for that is two things. First, don't be afraid, because like you pick these things up so quickly, like once you're on a job. And I was very lucky to have a mentor who was an excellent teacher, but there are so many online resources, and when you're really working, you can pick it up quickly. And the second is doing your own project, and not just building a model, because that's only part of most data science roles, but really trying to do it end to end. So for example, deciding something like, say you like wine, so you want to build a wine recommender application, then finding the data set, setting up a GitHub repository, which is free, and just learning how to work with Git and do all that. Trying to maybe, once you've built the model, serve it in a web application, which you can do, find loads of tutorials online or in Medium on how to do that with like a library within Python, and even try yeah, some of the other things like data quality checks or the stuff we just talked about. So rather than just focus on pure data science, try build a project with all the extra bits that make it a fully fledged product. Yeah.
That is great, and I concur really. And I just want to flick in that there is not only data scientists that's needed when building AI. We need business professionals, and we need marketeers and communicators and everything. So you don't need to be an engineer to do this. We will need all hands on deck to build this sustainable future with AI.
Granny, thank you so much. This was an excellent presentation. I hope everyone sees this. This is amazing. And I can't stress enough I love that you brought that up, the augmented intelligence part. In how do we that is really the effect we want to achieve. How do we augment and how do we scale our own intelligence to make better decisions? Thank you so much. If people want to reach out to you and have more questions, what do they do?
Yeah, so I am available on LinkedIn, and yeah, you can search me. There aren't too many Grania McNice out there. And you can also email me, and I'll just share my email in the chat. And yeah, I really like talking. So if anyone has questions or curious about Spoke or about data ethics or have ideas, yeah, definitely reach out.
Perfect. And we'll also share your presentation with all the links in the Slack channel, so you can go through that.
Cool. Okay. I guess I will leave, but thank you very much for hosting me. And yeah, good luck to everybody with the course.
Thank you so much,
Granny.
Take care.
And with that said, we want to wrap this up as well. This was really a fantastic presentation. Jonna, thank you so much for bringing Granny into this. And next time we'll talk about the real world AI, how that is being used today, both on a positive side, but also, of course, on a negative side with the or potential negative side with that in mind, with what Granny introduced here. There's some really interesting points here that I think we want to come back to. So next time is the 1st of December. We'll talk about real world AI, and then then we're going into instead of bi-weekly, we're going to every week. So that will end this course by Christmas. So it's real world AI on the 1st of December. Then machine learning and a deep dive into deep learning on the 8th, and then society and the transformation with AI on the 15th. Join the Slack channel. I think these discussions will continue there. I will share, because I love that she brought up augmented intelligence. I will share a talk also from, I think it's from Davos, with Ginny Rometty, the chairman of IBM, who talked about just this fact that we should probably call it augmented intelligence instead of artificial intelligence. That is also really valuable. So join the Slack. I'll share the link to that talk there. Thank you so much for contributing today. If you want to reach me or Jonna, use the Slack channel. You can reach out to us on our email or on Twitter or on LinkedIn. LinkedIn is probably the best way. And I hope to see all of you again in 2 weeks. So bye, everyone.